What's up, everybody? George T from the Wagon here. Today I got my friend Jason Weiler here, and we're going to have a little bit of discussion about belts today and the importance of running the right belt with the right pulley setup that you have on your Volkswagen. So Jason, what is it that you want to go over about belts today?
Well, there's some myths that want to bust about belts and get people to run the correct belt for what their system is. Also go over some of the systems that are out there and V-belts and versus flat belts and any serpentine belts. Yeah. So there's some history behind it. Obviously, Volkswagen did make some changes in the belt, but they chose the V-belt because it requires it's the easiest system to run, and it gives gradual wear over time. So the V-belt itself, just creates a wedge that drives the components, which are the fan and the alternator or the generator. So they had a few different sizes over the years. So it started 49 to 60 or in that range with the 9.5 by 900. That's generally the 36 horse belt, and it took 4 horsepower of friction, and friction is what is here running the generator and the fan.
So the motor actually loses a little bit of power. Obviously, in order to create the power to charge your system, it's going to pull some power from the motor, and what you're getting with that is requiring 4 horsepower draw to charge your battery and keep everything functioning in your car with the 9.5 by 900 on a 36 horsepower. So that would be your smaller generator, 6 volt. So our next series would have been going from 61 to 73. So this would have been all your 40 horses and up all the way to 1600 that were running generators. So that one is requiring a 5 horsepower draw to charge your system once we get into the generator. The only difference being the doghouse requiring 5.5. What's the difference between the doghouse? Would that be an indication to the fan, or what is that going from?
They increase a couple of things. They increase the wattage on the generator there, as well as the fan getting a little wider. So those are the two events there that go from basically 5 to 5.5 horsepower. Most of that half horse is in the fan on this one. The 9.5, 905 belt still worked in this system. The bigger change happens when they add the alternator to the system here, 73 to 79. The alternator takes even more friction to run it. The more wattage or the more amperage that any of those components are able to produce, the more horsepower it takes to actually produce them. So energy doesn't just come from nowhere.
No free ride.
So that's where we go from 5.5 to 6 horse.
And this is assuming that you have a 55 amp alternator. If you have anything aftermarket, you've most likely increased your amperage, which is going to increase the draw on your engine with that. Because of that, and a lot of people don't know this, so most aftermarket belt systems are not designed for this. The 11.3 by 912 belt was the factory alternator belt. Most aftermarket systems that are out there right now, a lot of them don't accommodate the 11.3 depth on the bottom pulley. Obviously the top is going to be adjustable because with shims and whatnot, but on your bottom, if that groove is not deep enough, this 11.3 cannot bed into that pulley. And this is actually an important thing that we've had a few discussions about, because when you're running a smaller belt, you lose the efficiency of that belt. And if you're running the proper belt on your motor, it's going to last longer on aftermarket pulley systems. If you're running stock, this should fit like a glove if you have a stock or a stock pulley on bottom and top.
Yeah, and generally speaking, wider is better when it comes to the V-belt. So you can use the 11.3/912 on a 36 horse without issue.
Okay.
But using the 9.5, 900 on a large, alternator system is a no-no. And what the reason is because there's some functional changes in the belt and the way it's actually constructed that kind of give it better wear properties. So you'll see some threading, some backing in there. The wider belt is just a little bit more structurally stiffer, right? So it's not going to have issues with any of the slippage or flipping or things like that that'll happen on a belt that is wrong for the system. And that's some of the issues that you'll find using the wrong belt on a more modern system. Is you'll see both slippage or that where you actually flip. I'm sure everybody's kind of
had a flip belt. You over-rev your motor a couple times, it'll happen.
Yeah, and
or you just keep your belt too loose for too long, it's going to happen on you as well.
So that's a first indication that you're using the wrong belt for your system. And obviously tensioning and things like that can have some issue, some kind of effect on that as well. But it's it's usually the wrong belt for the system.
What's the difference between going cogged or a smooth V-belt?
Cogged belt is just a little bit more efficient than the smooth V-belt, and it gives a little bit better cooling. So the ability for it to kind of conform is where they're getting the efficiency, and the cooling there is obviously a big thing. The belt stays cooler, it's less likely to wear. It's for wear properties is what the Cogged's for. So it's definitely a more modern take on the V-belt, and it's what you should run. You should look to run a Cogged belt.
All right, we're going to go step over the table now and show you some of the items that we're talking about between a smooth and a Cogged belt, and also the way a belt beds into that pulley for proper use. All right, so here we have a couple examples. We have a Cogged belt, and this is the 11.3 by 912. This is the V-belt I just took off of my engine. You can see a crazy amount of wear on this belt. There's actually a groove on it there. It's constantly under tension and resistance, which I think is one thing that gives you this premature wear on your belt. Whereas when you have a Cogged, you have a little bit of gaps. Those gaps allow for the friction to be cooled off. It allows it to bend at a deeper angle without putting stress onto your belt for it to do it, because you'll notice they'll start to split after a while as well. So that little relief right there allows it to conform to upper and bottom pulley and not really affect the belt too much. So we're going to talk about bedding into your pulley. So this is actually a good pulley. I believe this is an Impy sand seal pulley. Just, I'm not a big fan of chrome, so it's not on my motor. But you look at the groove there, and we're going to drop that 9.5 in there. This is a 9.5 by 905 right there. So this would be our second generation belt. And I don't know, the camera's going to pick that up, but you can see how deep that is in the groove right there. Not really the most efficient use of that space, in my opinion. Now let's take 11.3 by 912, your factory alternator belt. Look how that dude beds in there. So when you see that, look how nice and flat that is. You're getting the most out of that belt right there, because every bit of that belt is what's going to be turning your alternator and taking the power from your crank and using it to make the power for your vehicle. Every millimeter of that belt is being used, as is the pulley. So that's just a much more efficient use of space.
So I think it's good to note too the difference in construction of this belt. You can see, if you can see here on this belt, they've got some threading on there, and it's got a lot more backing than this belt here. So if you put those together, that's the size difference. But even construction-wise, if you look at the two belts, there's a pretty big difference in how these are constructed. And you can see on some of this where he's got some shine spots. Anytime you have slippage on your belt, it's done.
Yeah.
It will get you home, but anytime you have a slip on your belt, it's time to change the belt. So if you see any of these shiny spots on your belt, it needs to be changed.
This belt here actually did get me home. I broke down on the way from Octo. I lost my fan belt. It had been on my car for 4 years. My fault for not checking it frequently enough. So we put this one on my bus to get it home, and you see the improper fit, how bad it did. Another issue it created was my pulley, and this is a really nice expensive pulley, but it gouged it. I mean, there's an absolute gouge there, a good millimeter in height right there. This used to be a smooth surface, but because the wrong belt and the wrong tension on it, it prematurely wore out that pulley, and you can see it was starting on the other end. All the hard anodizing is completely gone from the belt surface. And another thing that Jason and I were discussing on this one here is the way that it holds its tension. You can see all the wear in what's supposed to be holding it captive, like there, but this pulley still moves. The top one moves separate from that bottom one. So this is going to be another one of your wear points on aftermarket pulleys. And this was a great pulley. This has been on my car, I believe 4 or 5 years now that I've had this, and it worked great. I didn't have any issues with it until I put the wrong belt on it. That made the biggest difference in this and absolutely destroyed a really nice and really expensive pulley right there.
The problem with a pulley like that though is once you see that wear, once you see that movement back and forth, that's just going to
it just gets worse.
It's just going to exaggerate over time, and you're probably using a steel nut on the outside of that one, so it helped kind of keep things together. But over time, aluminum does wear a lot faster than steel. So any of that motion, that rocking motion, will basically premature failure out of the pulley. So, you know, when you're talking about crank pulleys or alternator pulleys, it's important that the grooves are correctly machined, but it's also important that they tell you what belt they're for.
100%.
And it was a frustration of mine always that, you know, the proper belt wasn't spec'd to the pulley. Really good news that this one is correct for an 113912. I see tons of pulleys out there, aftermarket pulleys,
absolutely
high performance pulleys that do not have the right belt attached to them. They're made for a 10, and if it's made for a 10 belt in our modern kind of world of building these cars, it's the wrong belt, period. You can always go wider, you can't go the other way, because then you have issues with revving and all kinds of things, where these belts, just because they're not structurally as sound as these are, these will pillow out. So as you rev them, they will pillow more. Then you have the problem of actually skipping over the alternator generator pulley and flying off and chucking.
Absolutely.
So the chucking issue is largely related to the wrong belt. There could be other things, but the wrong belt, wrong pulley system, you end up slipping or chucking or flipping, and that's kind of what you want to get rid of, 100%.
When he's talking about modernizing, the majority of cars that they're running on alternator systems, the majority of them have doghouse shrouds, and the majority of them have the bigger fan that goes with everything. So to have as much belt surface as possible to keep all these modern items going is what you want. So you want a pulley system that's designed for your application on your car.
People say, all right, I don't want to use a V-belt system for X reason, or I want to use a serpentine system for X reason, or I don't want to use that system. So that's really where this kind of comes in. So the simple V-belt system still works for just about every application, minus drag racing. You know, when you are dealing with a revving car, a car that revs, and maybe a hot street car or something like that, it's important to have a fan that's welded and balanced. Your last video kind of went over that. So, and there's differences in a welded and balanced fan. So people will say, I want the belt to slip so that I don't blow up a fan. So the first myth is right there. I want belt slippage. So at no point do you want.
So what's wrong with belt slippage? What does that do?
Once the belt slips, it's done, right? And at that point, you're not turning your fan, which is also bad for your cooling.
Now, is that because you glazed it with a slip, or what is the reason why?
Primarily, once it glazes, it's just going to be too slippery on those surfaces. You end up with a slip belt is going to slip again. There's no way around it. As soon as it slips or chucks, it's going to do that again. You can eliminate the fan issue with a good fan. You know, using the correct belt and having it not slip at high RPMs, still turning the fan and not blowing the fan up. So that's kind of the first myth that's out there is I want slippage. You never want slippage. Volkswagen never engineered in slippage. Nope. They can't do that.
If you're trying to engineer failure in, you're going to get that. You're going to get a failure.
On high RPMs, if you're running just this kind of standard 10 belt, they will pillow up. And that pillowing kind of extends, and it's easy for it to extend over the alternator generator pulley, and that's where you get a chuck, or certainly they can just flip over.
I would assume that would also mess with your tension that you have set, because you've set the tension with the belt in place, and as soon as the belt leaves, things can actually loosen up at that point, I would almost think.
And it's good to remember that there is a tension side and a slack side. So the right side of the belt is your tension, that's your pull side.
Okay.
And then that left side is your slack side that you set stock. That needs to stay. And again, that's going to change by your belt size, like how tight that is. These ones tend to get tighter a lot quicker. They're remaining slack, and it exaggerates as you accelerate. Serpentine belts, the idea that they don't slip, well, that is somewhat debatable because we've seen them slip. Some people say, well, I don't want to run that system because it over revs the fan. Well, we already talked about the fan, so that's not a reason not to run that system. The biggest reason that there's issues with the serpentine belt is because the flat belt adds, significantly more friction to the system. Just a flat belt that was without a tensioner, you're talking about a major increase in surface area, and that is horsepower.
So it's parasitic drag.
Correct.
By adding the serpentine belt.
Yes, and then once you add a tensioner in, you're going to where you're dealing with 75 or 80% surface area coverage of the pulleys, right? So what happens there is that's again added friction. The more surface area of the pulley that you're covering, the more friction that you're creating. So that is on those systems we've tested, it's 7 horsepower more than what a standard V belt.
So what he's referring to is the actual amount of area your belt is covering. In a standard operation, you'd be running somewhere about like that. Well, when you're running a serpentine setup, you're usually pulling in on one side. So now you have all of this surface area is always under tension. So you've created friction throughout that entire space there while your tensioner is holding tension on here. Same thing applies to your upper. Instead of it just being like this on the upper, you're pulling further down on the upper, so you're getting probably about 75% coverage as opposed to just getting 50% like you'd have on a V-belt system, maybe 55. But.
Yeah, and on a V-belt system, you can add tension without putting extra pressure on your load components. So let's say the alternator or even the crank bearings at the point, your rear bearing, all of that's actually getting loaded on a flat belt system, on a serpentine system, whereas you can go with bigger belts, you can add tension on a V-belt system, and it doesn't actually add anymore. So the horsepower
it's not actually pulling.
It's not pulling anything down, right? So, and it's one of the things that guys do not do. In my experience, they don't go to wider belts. They'll try a serpentine rather than just going to a wider belt. There's nothing wrong with the V-belt system. It's actually adequate. Porsche uses it on horsepower levels that are far more than we're actually. 400 or 500 horsepower. Cars are still running, even with their bigger fan, even with their alternator, they're still running a V-belt system.
Well, Jason, thank you for coming in today.
Thank you.
We appreciate it.
All right.
And I hope you guys learned something today. There's more to this game. Dig into it. Look into what you're doing on your car. Make sure if you're buying product, it's going to be running the proper size belt for what your application is. And like I said, most of you guys out there have alternators. I know I'm an alternator guy. Look into it before you're buying it. Take it easy, guys. We'll see you next time.